Hello, my name is Yuni Lee. I'm working in College of Pharmacy in Seoul National University. I'm so excited to show you my recent research work, which is published in Nature Metabolism in this month. My laboratory, in collaboration with Dr. Grandman's and Dr. Sang-Gyu Lee's laboratory, we investigated the role of hippokinase in adipose tissue and found that the STK3/4 regulate mitophagy and energy metabolism by targeting BNIF3, which is the major players that regulate stress-induced mitophagy. Let me introduce background information on adipose tissue remodeling. Adipose tissue can be subcategorized into white and brown adipose tissue. White adipose tissue store energy as a triglyceride, and also it can mobilize free fatty acid when the energy is needed, such as fasting condition. Brown adipose tissue contain a lot of mitochondria, and increasing brown adipose activity can facilitate energy expenditure. Thus, the brown adipose tissue could be a great target to treat obesity and obesity-related metabolic disease. So the catabolic remodeling of white adipose tissue into brown adipose tissue is one of the great target for the metabolic disease, and mitophagy and mitochondrial biogenesis could be a great mechanism that explain the catabolic or anabolic adipose tissue remodeling. The representative physiological role of hippo signaling pathway may be the control of organ size. And the recent research suggested that hippo signaling also regulate energy metabolism. Hippo signaling contains several kinases. The upstream kinase is STK3 and STK4, which also called it MST1 and MST2. And the major canonical downstream signaling pathway is YAP and TA's regulation of transcriptional control. To test our hypothesis, we first examine the expression level of MST3 and MST4 in adipose tissue. As you can see, STK3 and 4 expression level were higher in visceral white adipose tissue in human, and the cold exposure can reduce the expression level of STK3 and 4. But interestingly, the canonical YAP TAS downstream targets were not affected by the cold exposure, and it's not related to the expression level of STK3 and STK4. To further test our hypothesis, we investigated the metabolic phenotype of adipocyte-specific STK3 and STK4 double knockout mice. And to identify direct target of STK3 and STK4 in adipose tissue, we performed phosphoproteomics analysis using adipose tissue obtained from wild-type and STK3/4 knockout mice. These analyses identified novel target of STK3 and STK4 in adipose tissue, and we confirmed that BNIF3 serine 88 is one of the direct target of STK3. Thus, our working hypothesis is that obesity or hypoxic condition increased STK3 and STK4 expression level and phosphorylate BNIF3 that facilitates BNIF3 mediated mitophagy, reducing mitochondrial level in adipose tissue. Indeed, genetic knockout and pharmacological inhibitor of STK3 and 4 increased mitochondrial content and improved the glucose tolerance in high-fat diet-induced obesity model. Thus, we concluded that STK3 and STK4 mediates mitochondrial remodeling in adipose tissue, And this hippokinase could be a therapeutic target to treat obesity and obesity-related metabolic disease. Lastly, I'd like to acknowledge the contribution from our laboratory member and also faculty in College of Pharmacy, Seoul National University, and also Dr. Grandman and Dr. Sang-Gyu Lee, who supervised this work together, and also Dr. Yoon for K-mice, Dr. Song for Metabolic Phenotyping Center, and Dr. Bae for Human Sample. You can find more story in Nature Metabolism webpage. And if you have any question, you can email me through this email address. Thank you very much for your attention.